So here we go. This was our packet. So in the first one, it was a quadratic. It's a degree of 2. It's approaching positive infinity as x approaches positive or negative infinity. The x and y intercepts are both located at the origin. And here it is tangent because it touches and bounces back. Any questions? All right. Okay, so the next one, all they did was make it negative. So all the negative did was reflect it over the x-axis. It's still a degree of 2, but this time our end behavior is approaching negative infinity. The x and y intercepts did not change and is still tangent. So A opened up and the end behavior was approaching positive infinity. But B opens down, so the end behavior is approaching negative infinity. So that's what we should notice. Both of these are even functions, the same degree. And the positive one, positive infinity, the negative one, negative and negative infinity. The end behavior was the same on either side, but the differences between A and B was one opened up, one opened down. Any questions? Okay, C. This was our first cubic. This is actually the parent graph for a cubic function. And it looks like a squiggle, doesn't it? Okay, do you see the inflection point here at 0, 0? Okay, concave down to concave up. Okay, so it's kind of like a squiggle, happens right here at 0, 0. So this one approaches, as x approaches negative infinity, y also approaches negative infinity. And as x approaches positive infinity, y approaches positive infinity. The x and y intercepts were both at 0, 0. But this time it passed through. So this factor was raised to an odd power and it passed through. When the factor was raised to an even power, what happened? It was tangent. It bounced back. So that was one of the things we went over yesterday quickly in part K. Now, how are these similar? They have the same x and y intercepts. How are they different? A and B had that tangent. It bounced back at the 0, and C passed through. All right, D. So this is exactly like C, except there's a negative out in front. So it's just going to switch that end behavior. So as x approaches negative infinity, y approaches positive, and as x approaches positive, y approaches negative. The x and y intercepts did not change. It still passes. So how does this compare to C? It has the opposite end behavior. But they still have the same x and y intercept. So that's the 0 didn't change. Any questions? Okay, E. So this is a third degree function. How do we know? Here's 3 factors. And with factors, we would multiply them, right? So really we're thinking x to the first times x to the first times x to the first is x to the third. So this function has a degree of 3. Make sense? All right. So when you graph it on your calculator, it looks something like this. We have an x-intercept here at -2, one at 0, and one at 1. Do you see where they come from?
Yeah.
Okay. That's where they come from. All of these are raised to the first power. When they're raised to the first power, it's going to pass through, pass through, pass through. An odd power passes through the point. If the factor is raised to an odd power, that's called root behavior, because we can call these the roots of the function. And so sometimes it's called root behavior. What's happening at each of the roots? If the factor is raised to an odd power, it's going to pass, just like it did here. Now, this has a positive leading coefficient. Did you notice that the end behavior was the same as C? It's an odd-powered function. As x approaches negative infinity, y approaches negative infinity. Goes down. To the right, as x approaches positive infinity, y approaches positive infinity. Goes up. If the degree of the function is odd, and the leading coefficient is positive, that's what the ends of the graph do every time. Every time that we're looking at polynomial functions. All right, so all of these pass through, so our x and y intercept are still 0, 0. But we have additional x-intercepts. So it's similar to C and D because it's a third degree, but it has more x-intercepts, doesn't it? Because it has different factors. Now, when you graph this, did you notice that it kind of passed through with a straight line? Straight line, straight line. So where it passes through, there was no inflection. There's no inflection if it's raised to the first power. Versus this third power, a higher degree factor, has that inflection point where the concavity changes at that point, an inflection point. Does that make sense? Okay. All right. Good enough for E? Okay. F. So similar to the one before, we still have the same x-intercepts. We still have the same y-intercepts. It's still passing through all of our zeros, but because of the negative out in front, now this got reflected, didn't it? It's going to, as x approaches negative infinity, y approaches positive infinity. It rises to the left and falls to the right. So this one's similar to E, it's just that reflection. But we have a different end behavior because of that. We good? All right. G. Okay, so let's look at it. 2, 3, 4. The degree of this function is 4. When you had a polynomial function that has an even degree, the ends are the same. It's either going to be positive and positive or negative and negative. The end behavior is the same. So because this is a degree of 4 and a positive leading coefficient, we have rise to the left and rise to the right. Okay, this one is going to pass through at -2 and +1. Look at these factors. Odd power for that factor. Look at this factor. Odd power for the factor. Odd passes through. Versus, look at this factor. What is the root behavior here at 0? Because it's raised to an even power, it is going to bounce. It is tangent there. So, when we're looking at root behavior, we're looking at the power that each factor is raised to. Even bounces, meaning it's tangent. Odd passes through. If it's just to the first, there's no inflection. If it's a higher odd power, there's an inflection where it passes through. Any questions? All right. Do you see how the things we were supposed to gather from this would have helped us graph all of our graphs? Okay. All right, negative and odd. Negative and odd is rise to the left, fall to the right. Let me show you how I can graph this without looking at a calculator. I know my zeros. There's one at 0. There's one at -2. There is another at +1. The degree of this function is odd, and the leading coefficient is negative. So I know it's going to rise and fall. Okay, now I'm going to individually look and see what happens at each root. So -2. -2 is raised to an even power. Tangent or pass? Tangent. So I'm going to make it bounce back. Got it? Okay, now let's go to my next one. 0. 0 is raised to the understood first power. Is it going to be tangent or pass through? Pass through. So I don't know exactly where this hill curves, but I know that it's going to do that. Okay, last one, positive 1. It's raised to an even power. So is it tangent or pass through? Tangent. So it comes up, it hits, and then it goes back down. This is what you can do to graph the functions without a calculator. Okay? All right, so this one, it gave us the window. We look at our graph. We say everything. Even power, bounces. Even, bounces. Even, bounces. The degree of the function is 6, which is even. Do both ends go in the same direction?
Yeah.
Yes. And that direction is down because the leading coefficient is negative. Okay, so here we go. Let's do it together again. It has a degree of 2, 4, 5. The degree of the function is 5. Will the ends of the graph go the same direction or opposites?
Opposite.
Opposites. So it's 5 and the leading coefficient is positive. So I know it's going to fall to the left and rise to the right. Now let's plot those x-intercepts and think about our root behavior. Looks like we've got one at 0, -2, and +1. So we know it's going to fall, rise. Good? Okay, let's look at the -2. Let's look at that root. What is the root behavior here? Tangent or pass?
Tangent.
Tangent. Okay, now let's look at my next root. Tangent or pass? Tangent. Let's look at my last root. Okay. Got it? And we have sketched the graph. Now, is the graph perfect? No, because we don't know exactly where these extrema occur. We don't know how deep these valleys are. But is it close? Yes, it's really close for not having a calculator. Okay, we did this yesterday. If there's anything you guys need to add, this may not be the exact verbiage I used yesterday, but it's the same idea. Okay, so several of you struggled on the graphs last night. Do you think after listening to it being explained, you could do them? Yes. Okay, cool, because that's what we're doing today. All right, let's see if the answers make sense, even if you didn't get them all correct. So you were supposed to do this without a calculator. All right, so if we look at this one, the degree of the function is 1, 3, 4. So, and it's positive. So since it's positive and even, we know the ends are going to do the same thing. So we could cancel out C. We know it can't be C. We know the zeros are at 0, 3, and 4. So we need one at 0, 3, and 4. 0, 3, and 4. It's got it, -4, excuse me, -4. Sorry. It's got to be D. Okay? And we could use process of elimination on these. So it was D, C, B, A. Nice and backwards. Any questions about these? Okay. All right, so let's look at this one. Degree of 5, negative leading coefficient. Going to do them quickly together. So degree of 5, negative leading coefficient tells me it's going to rise to the left and fall to the right. I have a 0 at 0, and I have a 0 here at +5. And I'm going to have to come sit and face because I can't. Okay, at 0, know the end behavior is rise, fall. Okay, at 0, this is a third degree. Is it going to pass through or is it tangent? It's going to pass through. Now, because the degree is odd, it's going to have that inflection. So it actually is going to do like that.
Yay.
And then we're going to come back up here, and let's talk about the root behavior at 5. Is it going to be tangent or pass? Tangent. Got it? And that's how you do all these. Degree of 6, positive leading coefficient is rise to the left, rise to the right. We're going to have a tangent root behavior at both of them. Okay, this one took a little work, didn't it? You had to factor, and then we had to factor some more. So if we look at it in this form, we have the 2 x plus 2 squares, and we had 2 of the x minus 2's. So if we're thinking about root behavior, it's going to be tangent, tangent. So it's going to bounce and bounce. Yeah. Okay, so now write an equation for a polynomial whose graph has the following characteristics. As x approaches negative infinity, y approaches positive infinity. And as x approaches positive infinity, y approaches positive infinity. Okay, so we know it has to be an even degree function because they have the same end behavior. And because it's approaching positive infinity, our leading coefficient must be positive. Okay? Now, we know it's tangent at both of its x-intercepts. So these have to be raised to at least the second power. Could be the fourth, could be the sixth, but at least the second power. Okay, now, if you had done the fourth or the sixth, you would have gotten a different y-intercept. But if you went squared and squared, we should have the same. Because when we plug in 0 for x, we get 25 when we square this, right? And when we plug in 0 here, we get negative 2 squared is 4. And 25 times 4 is 100. And that's how we would get that intercept. So, what are our big ideas? End behavior, root behavior, and whether it's and checking out whether your leading coefficient is positive or negative. So, the degree of the function is the highest exponent when we multiplied everything out, if we're given factored form. So if it's even, we know the ends are going to do the same thing. It's rise, rise. If it's a positive leading coefficient, it's fall, fall. If it's a negative leading coefficient. Once we determine the degree of the function is odd, if we have a positive leading coefficient, it's fall to the left and rise to the right. If we have a negative leading coefficient, it's rise to the left and fall to the right. Okay, root behavior. What is happening at the roots of the function? If a factor is raised to an even power, then it is tangent, which means it bounces at that x-intercept. But if the factor is raised to an odd power, it'll pass through. It passes through similar to a line. If it's raised to the first power, there's no inflection if it's first power. And with an inflection, if it's a higher odd power. Got it? Okay, then today's stuff will be easy.
You got it right.
It's just more practice.